Okay, this is a continuation of Learning Target 10.1 still, where we're figuring out the number of permutations or combinations that there could be for the total number of outcomes of doing some sort of event or experiment. Okay. So what we haven't talked about yet is permutations with repetition. Okay. And that would be doing something like finding the number of ways to arrange the letters in the word T-H-A-T. Okay? We already did something like this. In fact, we used that for an example yesterday in class. How many ways can you arrange the letters in Zach's name? 24, and how did you get that? 4 times 3 times 2 times 1, or 4 factorial, right? So there'd be 24 different ways to arrange the letters in the word Zach, okay? You know, we do this a lot. How many letters could I put here? 4. How many here? 3. How many here? 2. You know, 4 times 3 times 2 times 1, or 4 factorial, okay? Now that's how many ways you could arrange the letters in the word Zach, okay? And they would all look like different arrangements, right? They would all be different arrangements, okay? If you tried to do that with the word that, okay, you wouldn't get 24 different arrangements, okay? Because if I switch this T and this T around, will it look like a different arrangement? No, it'll be the exact same word because the T's are not distinguishable. They're all uppercase, okay, they look identical, all right? So when you have some repetition, some things that repeat themselves, you got to take into account that those two things aren't different from one another, okay, and there would not be then as many ways to arrange the letters in the word that, okay. Now, if all the letters were different, the answer would be 4 factorial, right? Okay, if all the letters were different, it would be 4 factorial. But they are not, okay. How many letters are there that are identical? 2 of them, okay? So there are 2 T's. There are 2 T's. How many ways could 2 letters be arranged? 2 factorial, right? Okay, if they were different, okay? My question is, how many ways could 2 letters be arranged and that would be 2 factorial, which yes, I know is just 2, but I want you to think of it as 2 factorial. So every one of those ways that the 2 T's could be arranged, we need to then divide out from this number right here. Okay, because every single one of those, if we would just do 4 factorial, you'd see some repeats because the 2 T's are interchangeable basically. Okay, so you'd actually need to do 4 factorial divided by 2 factorial because we have 2 T's, and every time you just switch those T's around, it looks the same, so you need to divide out those 2 factorial ways that the T's could be moved. Okay, so my answer is going to be 4 factorial divided by 2 factorial, which is 24 divided by 2, which would just be 12. So there's only 12 ways that I could arrange the letters in the word that. Yeah?
So if there are 3 letters that are the same, you just divide by 3 factorial?
Absolutely, and that's where I was going with it next. Yep. If there were 3 letters that were the same, okay, let's say you had the word sass, alright? How many ways could you arrange the letters in the word sass? Well, again, if they were all different, it would be 4 factorial. But now, are there any letters that repeat themselves? Yes. How many of those letters are there? 3. How many ways could those 3 letters be interchanged? 3 factorial, so that's what you would divide by, is 3 factorial. So that's 24, that would be 6, so there's only 4 ways you could arrange those letters. Okay? Because every one of those arrangements of the S's, or in this case the T's, every one of those ways you can arrange them, you must divide those out of your total because they won't look different than the original. Okay? So, I'll leave that up here. How about, let's get crazy here, how about the word Mississippi? Yeah, there you go.
There's multiple different.
Now, how many ways could we arrange the letters in the word Mississippi? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 different letters. So if they were all different, you'd have how many ways to do it? 11 factorial. But there's some repeats, right? 4 S's, so we better divide by 4 factorial, because all of those S's could be distinct, or could be arranged 4 factorial different ways. Are there any other repeats? 4 I's, so we divide by another 4 factorial. 2 P's, so we divide by 2 factorial there. So we got the S's, we got the I's, we got the P's, that's it, right? There's only one M. Yeah, you could divide by 1 factorial, but that's like dividing by 1, so there's no need to do that. Okay? Now, when you go to do this on your calculator, alright, here's probably how I would enter it on my calculator. I would think you can get away without parentheses on the first part. You can just type in 11 factorial, but then don't press enter at that point. I wouldn't. I'd do this all in one step. Okay, but it's up to you. Divided by parentheses 4 factorial times 4 factorial times 2 factorial to get that answer. Okay? Use parentheses when you do it. And just for speed purposes here, I'm gonna, so 11, and you guys can do this too while I'm doing it, just to make sure I'm getting it right.
34,650. That's what I got.
$34,650. So 34,650 ways to arrange those. Okay? So anytime there's repetition of things, you need to divide by the number of repetitions of a particular character. Okay? Now, where potentially could I apply that into something that's not necessarily just arranging letters in a word? I could do it for maybe something like a cross-country meet. Okay? Let's say we got a cross-country meet, and just for, let's say we got 20 runners. Okay? Cross-country meet, 20 runners. Let's say there's 6 from team A, there's another 6 from team B, and then there's 8 from team C. Okay, that makes 20, yeah, okay. Alright, so you got 3 teams running this cross-country meet, small meet, I know. But anyway, only 20 runners running, okay? And you know that, maybe you don't, in a cross-country meet, okay, you get points based on how you finish in the race, okay? So, if Van Meter's 6 runners came in 2nd, 8th, 10th, 12th, 17th, and 18th, you take all those places, add them together, that's Van Meter's points for the night, okay? Then Team B, we'd add all their places together, and the team with the lowest number of points is the champion. Okay, that's kind of how they award team champions in a cross-country race. Okay, well, I could ask you, all right, well, how many different ways could these people finish the race as far as teams are concerned? Okay, and as far as teams are concerned, if Tyler and I are both running for Van Meter, if he comes in second and I come in fourth, does that really matter if I was in second and he was in fourth, as far as the team points are concerned? No. So really, we're just all VMs. All right? We're all V. All right? So it's like, or in this case, A. So really, all 6 people are A's, another 6 people are B's, another 8 people are C's. So really, what you have here is a 20-letter long word that has 6 A's, 6 B's, and 8 C's in it, and I want to know how many ways those could finish in the race. So you'll do it just like you do the word Mississippi. All right, how many letters long is the word? 20, so I do 20 factorial, and I divide by what? 6 factorial, 6 factorial, 8 factorial. Because it doesn't matter who on this team A finishes second, who gets 5th, who gets 7th, and so on. Okay, you're a school, all right? You're Van Meter. So you can kind of think of this as a repetition type thing. That could tell you how many different ways the race could be finished and team points could be awarded. All right? So that's kind of the permutations with repetition thing that I haven't talked about yet. You should be able to do that set of problems now in the assignment. I'll stop the video here and then I'll teach more when you guys are ready. I'll take some questions probably first though.